Hi everyone, so welcome to the channel. So in the previous video we have discussed about the proof of Pythagoras theorem, and in this video we are going to discuss the application of Pythagoras theorem by solving some of the problems related to them, right? So before going to start the video, so if you are new to this channel, so please subscribe the channel and share with your friends and give a like to the video, right? So let us begin with the first application. So the given question is, a ladder 25 meters long reaches a window of building 20 meters above the ground. Determine the distance of the foot of the ladder from the building. So the question given is, so there is a ladder. So how will you keep a ladder? So whenever you are having the horizontal, so that is nothing but earth. So earth is generally represented with a horizontal line, and the building is always vertical with the earth. That means they make 90 degrees angle with each other. That means it is perpendicular to. So if this is my ground and this will become my building, right? Now giving the names for this, so let this be some ABC. Already you all know that ladder is always kept slant with the ground, right? So with the horizontal, so it will be making some angle. Okay, so here what he has given, ladder is 25 meters long. So it is 25 meters long, reaches a window of building 20 meters above the ground. So since this is the ground, so above the ground how much is the height? So height of the building is given as 20 meters. Now since this is a right angle triangle, so we can apply Pythagoras theorem, right? So what Pythagoras theorem states? So by Pythagoras theorem, so I am writing it in short, by Pythagoras theorem, or you can write it, so by Pythagoras theorem, what we can say from this figure, AC square I can write it as AB square plus BC square, which is nothing but hypotenuse square is equal to side square plus side square. When I substitute the values, AC is 25, so 25 whole square is equal to AB is 20 whole square. Since I don't know the value of BC, so let it be BC square. Now what is the value of 25 square? 25 square is 625 is equal to 220 square is 400 plus this is BC square. Now since I need BC square, for that what I am going to do, I am going to transpose 400 to the left hand side. So when I transpose plus 400 to the left hand side, it becomes minus 400, which is equal to BC square. So from this 625 minus 400 is nothing but 225 is equal to BC square. From this BC is equal to square root of 225. So square root of 225 is nothing but 15 meters. So from this what I can say, the distance of foot of the ladder from the building, the distance of foot of the ladder from the building is 15 meters, right? So this is my conclusion. So the same thing you need to write here. Okay, the distance of foot of the ladder from the building is 15 meters. So here we have used the Pythagoras theorem directly. So hypotenuse square is equal to side square plus side square. So to find out the unknown sides, so we are going to use this Pythagoras theorem. Next, moving on to one more question. So example number 12. So BL and CM are the medians of a triangle ABC right angled at A. So this is nothing but my right angle triangle ABC and right angled at A. Here BL, so BL is a median. So what is the use of median? So median divides the opposite side into two equal parts. That means AL is equal to LC. The same way CM is one more median, no? So this CM also divides this side AB into two equal parts. Here you need to observe this CL, AL are equal, but AC is not equal to AB. So that's why we are representing with a different notation. Clear? Now looking into the figure, see here L is nothing but midpoint, right? So if L is midpoint, then how can I represent AL as So AL and CL both are equal. So in terms of AC, if I want to represent, so I can represent this part as AC by 2 and this part also as AC by 2. The same way here AM and MB I can represent it as AB by 2 and AB by 2, because this total length is AB, they will become half of them, right? Now if you observe this figure clearly, CAB is a right angle triangle, and one more thing, CAM. So CAM is one more right angle triangle and LAB is one more right angle triangle. So totally we have 3 right angle triangles in this figure. Okay, that you need to understand clearly, right? Moving on to the solution. So what are the things that we have here? So we have AM is equal to MB is equal to, directly I can write as AB by 2, and at the same time I can write AL is equal to LC is equal to AC by 2. By looking at the figure we can clearly say these two things. So first of all we are going with the first triangle, the biggest triangle, and triangle CAB, CAB. So in triangle CAB, if I apply Pythagoras theorem, so if I apply Pythagoras theorem, what I can say? By applying Pythagoras theorem, we can simply say that BC square can be written as, so this hypotenuse BC square can be written as AC square plus AB square. So let it be my equation number 1. Next, moving on to, so we are having 2 more right angle triangles, so following one by one. In triangle CAM, so here if you observe, names are also somewhat familiar, CAM. Here in triangle CAM, by Pythagoras theorem, what I can say? Triangle CAM. So in this triangle, what I can say? What is the hypotenuse? So CM is the hypotenuse. So I can write it as CM square is equal to CA square plus AM square. But AM I can write it as, so already I know the value of AM in terms of AB. So simply replace AM with AB by 2. Then this becomes AB by 2 whole square. This again I can write it as CA square plus AB square by 4. On taking LCM, I can write this as 4 times of CA square or AC square, both are same. So 4 times of AC square plus AB square whole divided by 4. This is nothing but the value of CM square. So from this what I can say, when I cross multiply this 4, this becomes 4 times of CM square is equal to 4 times of AC square plus AB square. Now from this I am considering this equation as equation number 2. The same way, if I consider the third triangle, so what is the third triangle? LAB. So in triangle LAB, again by applying Pythagoras theorem, so what is the hypotenuse in this? LB. So LB square is equal to AL square plus AB square. So clearly this AL, already we have written the value of AL. AL I can write it as AC by 2 whole square. This I can replace it as AC by 2 whole square plus AB square. The same way when I change this, so AC by 2 whole square can be written as AC square by 4 plus AB square. Now this again by taking LCM I can write as 4 times of, so 4 is the LCM, so AC square plus 4 times of AB square. Now finally if I transpose this 4 to the left hand side, this becomes 4 times of LB square or BL square, both are same. So 4 times of BL square is equal to AC square plus 4 times of AB square. Now let this be equation number 3. Let this be equation number 3. Now if you observe here, what did he ask you to prove? 4 times of BL square plus 4 times of CM square. So already we have 4 times of CM square here and 4 times of BL square here. That means equation 2 and 3 I need to add, right? So what I need to do? add equation 1 and 2. So when I add equation number 1 and 2, what I am going to get? Left hand sides, so 4 times of cm square plus 4 times of bl square is equal to, here on the right hand side I have 4 times of AC square plus AB square, or plus here 4 times of BL square is nothing but AC square plus 4 times of AB square. Now on the left hand side what do I have? 4, if I take common, 4 times of CM square plus BL square is equal to, so here 4 AC square plus AC square is nothing but 5 times of AC square. So 5 times of AC square, AB square plus 4AB square is nothing but 5 times of AB square. So directly what I am going to do is I am going to take 5 as common. So 5 times of AC square plus AB square. But from equation number 1, AC square plus AB square is nothing but BC square. So instead of AC square plus AB square, I can write it as 5 times of BC square. So this is nothing but the value of 4 times of CM square plus BL square. So this is nothing but 4 times of CM square plus BL square. So how we got this AC square plus AB square is equal to BC square means from equation number 1. From equation number 1 we got this value BC square, right? So this is nothing but the proof of this particular question, right? So if you do it in order, so if you do each and everything in order, then you are going to get the answer in a simple way, right? Next, moving on to one more question, example number 13. So what he has given, O is any point inside a rectangle ABCD, then prove that OB square plus OD square is equal to OA square plus OC square. So this is the given question. So to prove this particular solution, what we are going to do is, so we have considered a rectangle ABCD and O is any point inside the rectangle. Next, after that what we have done, we have joined OA, OB, OC and OD. So that is the thing what we have done here. And after that we have drawn a line PQ which is passing through O. We have drawn a line PQ which is passing through O. So if it is drawn passing through O and parallel to the sides, then what I can say here, so I can simply say that these are perpendicular, right? So here these are perpendicular, so here also we are going to get the perpendicular things. Now if you observe the things, so totally we are having 4 right angle triangles: triangle OPA, triangle OPB, triangle OQC, triangle OQD, right? Now, and one more thing, here we can say that this part is equal to this part, right? And this part is equal to this part. Why? Because here we did not say that P is midpoint of AB, right? Since P is not the midpoint of AB, AP value will be equal to DQ value. AP value will be equal to DQ value because this line is parallel to these both sides. Okay. The same way BP value is equal to CQ value. Those parts, corresponding parts are equal. That's it. Okay. Now moving on with the things. So what are the things that are given, right? Let us see this. So from the figure what we have considered, ABCD is a rectangle, O is any point inside the rectangle. So passing through O we have drawn a line PQ such that it is parallel to the sides of the rectangle. Then automatically it will be perpendicular to the remaining two sides. Clearly from this what we got, AP is equal to DQ and BP is equal to QC. So these two things we have obtained from the figure, right? Now since I need OB square plus OD square, OB square plus OD square. Now where is OB? So OB is present here and OD is present here. So this OB is hypotenuse of this particular triangle, right? The same way OD is hypotenuse of this particular triangle. Now if you want to prove, then you need to take it in order. So first we will be considering the triangle OPB. In triangle OPB, what we are going to do is, so we are going to apply Pythagoras theorem. So in triangle OPB, by applying Pythagoras theorem, what we can say, OB square is equal to OP square plus BP square. The same way, here this OB square is equal to, so here OP square is as it is plus BP. So how can I write BP as? So BP can be replaced with QC, no? So I am going to replace BP with QC. So let it be equation number 1. Next, moving on to the next triangle. So the triangle OD. So where the triangle OD? So in this triangle OD is present, it is present in OQD triangle. So we are going with OQD triangle. In triangle OQD, same by Pythagoras theorem, what I can say, OD square is equal to OQ square plus DQ square. Now already beforehand we have written DQ is equal to AP. So replace DQ is equal to AP square. Then this becomes OB square, OD square. Let this be equation number 2. Okay, now since I need OB square plus OD square, so what I can do, I can add equation 1 and equation 2. So when I add equation 1 and equation 2, left hand sides will be added together and right hand sides added together. So OB square plus OD square is equal to, so here OP square plus QC square plus OQ square plus AP square. Right? Now rearranging the things. So here this OP square and AP square contains P as the common vertex. If I write those together, so OP square plus AP square, the same way if I consider this QC square and OQ square, then if I combine those two as one group, now if you observe this OP square plus AP square, so where is OP and AP? So OP and AP are present in this particular triangle, right? So OP square is one side and AP square is one more side. So side square plus side square is nothing but equal to hypotenuse square only, no? That means by Pythagoras theorem, OP square plus AP square, I can write it as OA square plus the same way QC square plus OQ square. So QC and OQ. So QC and OQ are present in this triangle, where OQ and QC are the sides. Sum of squares of sides is equal to square of the hypotenuse. Then this I can replace as OC square. From this clearly what I can say, OB square plus OD square is equal to OA square plus OC square. Right? So this is one of the results. So this is one of the results, so which we can directly use in a rectangle. So in a rectangle, if O is any point inside the rectangle, then this relation holds good. OB square plus OD square is equal to OA square plus OC square. Right? Next, moving on to one more question. The hypotenuse of a right angle triangle is 6 meters more than twice of the shortest side. If the third side is 2 meters less than the hypotenuse, find the sides of the triangle. So the question is given in this way. So first of all, what we are going to do is, so consider the triangle. So consider the right angle triangle. So when you consider the right angle triangle, then you will get a clarity, right? What he has given, the hypotenuse of a right angle triangle is 6 meters more than twice the shortest side. So here hypotenuse is being compared with the shortest side. Now consider the shortest side as some x. Consider the shortest side as some x. Then what he has given, hypotenuse is 6 meters more. So 6 meters more means, so it is nothing but plus 6 more than twice the shortest side. So shortest side is x, twice the shortest side means 2x. Then clearly my hypotenuse is 2x plus 6 meters. Next, what he has given, if the third side is 2 meters less than the hypotenuse. So already hypotenuse is 2x plus 6. 2x plus 6 is my hypotenuse. and he has given the third side is 2 meters less than. So 2 meters less means minus 2. So on simplification, what I am going to get, this becomes 2x plus 4 meters. Now clearly we got all the three sides of the triangle, right? So if we are having three sides of the triangle, then directly we can apply Pythagoras theorem. So solution by Pythagoras theorem, what I can say, this hypotenuse square, so 2x plus 6 whole square is equal to side square, so that is nothing but 2x plus 4 whole square plus x square. Now on expanding this equation, we are going to have 4x square, 2 6 are 12, 12 2s are 24x plus 36, because a square plus 2ab plus b square is equal to, here also I am going to have 4x square plus 2 4s are 8, 8 2s are 16x plus 4 square is 16 plus x square. Now when I transpose all these things to the right hand side, then what I am going to get, so here 4x square plus x square is 5x square plus 16x plus 16 minus, so this whole thing I am going to transpose, then this becomes minus 4x square minus 24x minus 36 is equal to 0. Then this becomes 5x square minus 4x square gives me x square. 16x minus 24x is minus 8x. 16 minus 36 is minus 20 is equal to 0. So this gives me 20 is equal to 0. Now what are the factors of 20, so that you are going to get 8? So factors of 20. So 10 2s are 20. So I can split this minus 8x as 10 2s. So here we are having minus, no? So this becomes plus 2x minus 10x minus 20. Because we are having negative sign here, so value which is having more should have negative sign. So from this what I can say, from the first two terms I can take x as common, then I will be left with x plus 2. From these two terms, if I take minus 10 as common, then I am going to have x plus 2 is equal to 0. So from both the terms I can take x plus 2 as common, then I will be left with x minus 10 is equal to 0. Now here x value can be minus 2 or x value can be plus 10. Now since x is nothing but one of the sides of the triangle, so side of the triangle can never be negative. Hence this minus 2 is not possible. Then only possibility that we have is x is equal to 10. So from this clearly what I can say, the shortest side, so shortest side is x is equal to 10 meters. Next other side, so other side is nothing but third side. So third side is nothing but 2x plus 4, which gives me 2 into 10 plus 4, which gives me 24 meters. The same way finally the hypotenuse, so hypotenuse is equal to 2 times of 10 plus 6, which gives me 20 plus 6 is equal to 26 meters. So likewise we can find out the sides of a right angle triangle when the sides are related with some conditions. Okay, next moving on to one more question. So example 15. So what he has given, ABC is a right angle triangle, right angle, let's see. Let BC is equal to small a, CA is equal to small b, and AB is equal to small c, and let P be the length of the perpendicular from C onto AB. Then prove that PC is equal to AB, and 1 by P square is equal to 1 by A square plus 1 by B square. So already we have discussed this result, right? Now let us see the proofs of this particular things. So moving on to the solution, if you observe this figure, so this BC and AC are perpendicular, right? BC and AC are perpendicular. Then we can say that BC can be taken as base and CA can be taken as height. or otherwise if you turn the figure, then this AC can be taken as base and BC can be taken as height. Okay, so there are two possibilities for this base. So either BC you can take it as base and AC as height, or AC can be taken as base and BC can be taken as height. There is one more possibility, so that is nothing but BA, which is nothing but AB can be taken as base, then CD becomes height. Okay, there are totally three possibilities. So you can take any of the sides as base, then automatically you are having its corresponding height. Okay, now what I am going to do is, so I am going to take area of triangle ABC is equal to area of triangle ABC. So can you say area of triangle ABC is equal to area of triangle ABC? So already those are the same triangles, so their areas will be obviously equal, right? Now first of all, what I am going to think is, I am going to consider this BC as base and this AC as height. So for this area of triangle ABC, I am going to consider this particular BC as base and AC as height. Then what is the area of triangle formula? Half into base, so base is BC into height is AC, is equal to, now for this area of triangle ABC, so what I am going to do is, I am going to consider this particular AB as base and CD as height. Then I can write it as half into AB into, what is the height? CD. So on both sides I can cancel out half because that is a constant, so half can be cancelled on both sides. Next, what is BC here? So BC is A into AC is nothing but B, so A into B is equal to, what is AB? AB is small c into CD is P. So from this what I can say, so PC is equal to AB. So the first thing we have proved. So this is the first thing what is asking you to prove, right? So first thing we have proved here. Okay, next one more thing, we need to prove this second result also. So to prove that, what I am going to do is, I am going to make use of Pythagoras theorem. So by Pythagoras theorem, what I can say, since right angled at C, no, so right angled at C means this particular C will be my hypotenuse. So clearly what I can say, C square is equal to A square plus B square. C square is equal to A square plus B square, right? But in the relation we don't have any C here, we don't have any C. So for that what I am going to do is, I am going to eliminate C. So to eliminate C, from the first result I am going to write C is equal to AB by P. I am going to make use of C is equal to AB by P. So this relation I am going to use here. So directly when I substitute C is equal to AB by P, this becomes AB by P whole square is equal to A square plus B square. Now from this I can write it as A square into B square by P square is equal to A square plus B square, right? Now clearly I need 1 by P square, no? So to get 1 by P square, what should I do? I need to transpose this A square B square in the numerator to the other side. So when I transpose A square B square to the other side, which is in the numerator, so will go into the denominator. Since it is A square plus B square, so I can give this A square B square to both the terms separately. So I can write as A square by A square B square plus B square by A square B square. Now here A square gets cancelled in the first term, B square gets cancelled in the second term. So clearly I can write it as, so 1 by P square is equal to 1 by B square plus 1 by A square. Since we have commutative property satisfying, so I can write it as 1 by P square is equal to 1 by A square plus 1 by B square. So this is nothing but the second result. So these are the results, so which we can directly make use of while solving the problems. Okay, so this is one more important result, so which we need to remember. right? Next, moving on to few more problems. So do this. So do this problem. In triangle ACB, angle C is equal to 90 degrees and CD is perpendicular to AB. Then prove that BC square by AC square is equal to BD by AD. Now if you have this figure in this particular way, you might get confused. So that's why what I am going to do is, I am going to draw the figure once again. Now this angle is C and this is my A and this is my B. So I have rotated this figure in this particular manner. Then from C onto AB I have dropped a perpendicular D. Okay. Now already while proving the Pythagoras theorem, so we had some results. By using the concept of similarity, so we had some results, right? So what is that result? So if I want BC into BC, so BC into BC means, so this part into this whole part, right? So clearly what I can say, so BC square is equal to BD into BA. So BC square is equal to BD into BA. So how can we obtain that? By considering triangle here what are the triangles? Triangle BCA is similar to triangle, since I need this first triangle, so I can consider it as BDC. So by considering the similarity of triangles BCA and BDC, so we can obtain this result. Okay, the same way if I want AC square, so where is AC square? So I want this AC, so AC into AC is nothing but this part into this whole part. So you can observe the notations how I am showing you. So for BC's I have taken the curved lines, for AC square I am considering the straight lines. So AC square I can write it as, so AD into AB, AD into AB. Since I need BC square by AC square, this I can write it as, so for this AC square I can obtain by considering the triangle, so the biggest triangle BCA similarity with the triangle CDA, triangle CDA. So on considering the similarity of these two triangles, you are going to get this particular relation. So BC square by AC square I can write it as BD into AB by AD into AB. So clearly AB I can cancel it out. So clearly I can write it as BD by AD. So this is nothing but my answer for this question. Understood? So when you know the results which are obtained from the Pythagoras theorem or during the process of Pythagoras theorem proof, so you can make use of them directly. Next, moving on to one more question. A ladder 15 meters long reaches a window which is 9 meters above. So already we have done this type of problem, right? A ladder is 15 meters long. So ladder means, so you need to consider a right angle triangle, so which is 9 meters above. So this is 9 meters above and a ladder is 15 meters long on one side of the street. So keeping its foot at the same point, the ladder is turned on the other side. So this is not the figure, so there will be a small change in the figure, right? See what he did. So first of all, he has considered a building. So he has considered this way. So it is 9 meters above and the length of the ladder is 15 meters, right? Then what he did, keeping the foot of the ladder at the same point, this ladder is turned onto the other side to reach a building of height 12 meters. So this became 12 meters, but this is the same ladder, no? So ladder's length will not change. That means this is 15 meters again. Now this is right angle and this is also right angle. Now what is he asking? Find the width of the street. Find the width of the street. So he is asking. So from here he kept on one side. Next, from the same point he kept on to the other side. That means this whole length is nothing but we call it as the width of the street. So this is width of street. So if you want to find the width of the street, so we need to find out this length as well as this length, and we need to add them together, right? So from this what we have, clearly we need to apply Pythagoras theorem twice. Okay, so first of all I am going to consider this particular triangle as ABC, then automatically this is CDE. Now what I am doing in triangle ABC, so in triangle ABC I am applying Pythagoras theorem. So by Pythagoras theorem what I can say, AC square is equal to AB square plus BC square. When I substitute the values, AC square is nothing but 15 square is equal to AB square 9 square plus BC square. So clearly 15 square is 225 is equal to 9 square is 81 plus BC square. Now when I transpose this 81, this becomes 225 minus 81 is equal to BC square. So 5 minus 1 is 4, 22 minus 8 is 14, which is equal to BC square. So clearly BC is equal to 12 centimeters. Sorry, not centimeters, it is meters. So this is 12 meters. The same way we need to go with the second figure. So what is the second triangle? In triangle CDE, again by Pythagoras theorem, what I can say, CE square is equal to CD square plus DE square. Now when I substitute the values, so this becomes 15 square is equal to, what is CD? So that is the thing we need to find it out. So CD square plus 12 square. Now clearly 15 square is 225 is equal to CD square plus 12 square is 144. So we can simply say that CD square is equal to 225 minus 144, which is nothing but 81. Clearly CD is equal to 9 meters. So this length is 9 meters. So finally what is the width of the street? So width of the street is nothing but 12 plus 9. So from this what I can say, this width of the street is nothing but 12 meters plus 9 meters, which is equal to 21 meters. So this is nothing but my answer for this question. Okay, next moving on to one more question. So in the given figure, if AD is perpendicular to BC, what he has given, AD is perpendicular to BC. So if AD is perpendicular to BC, so this is perpendicular as well as this side also we can consider it as perpendicular. Then prove that AB square plus CD square is equal to BD square plus AC square. So this is the given question. Now if you observe the figure, how many right angle triangles we have? We have two right angle triangles. One is ADB, other one is ADC. Okay, since we have two right angle triangles, so we can apply Pythagoras theorem twice. So first considering triangle ADB. So the left side triangle if I consider by Pythagoras theorem. So when I apply Pythagoras theorem, what I can say, since this is right angle, then this is my hypotenuse. Clearly what I can say then, AB square is equal to BD square plus AD square. So let this be equation number 1. The same way we are having one more right angle triangle, right? So what is the right angle triangle? ADC. For that also if we apply Pythagoras theorem, clearly since this D is hypotenuse, this D is right angle, this AC is my hypotenuse. Clearly then I can write it as AC square is equal to AD square plus CD square. Let this be equation number 2. Now since in the proof, so in the thing what we need to prove, we don't have AD square. So what we can do is, so till now we have added, right? So in this particular question we need to subtract. So when I do subtraction, so what will it become? AB square minus AC square. So left hand side we have subtracted is equal to, this becomes BD square plus AD square. So this is plus as it is. Since we are doing minus to the second equation, so this AD square plus CD square becomes minus AD square minus CD square. So clearly plus AD square minus AD square gets cancelled. Now from this what I am going to have, AB square minus AC square is equal to BD square plus CD square. Sorry, it is minus CD square. Now transposing the minus terms to one side, so transposing the minus term to either side so that they becomes plus, then what I am going to have, AB square, this minus CD square, if I transpose, this becomes plus CD square is equal to, here BD square already we have, this minus AC square will become plus AC square. Now if you observe, this is the thing he is asking you to prove, so hence proved, right? So these are some of the problems so which are making use of Pythagoras theorem, right? So thank you for watching the video. In the next video we are going to discuss the exercise problems related to Pythagoras theorem, right? So stay connected with the channel, so please share with your friends so that it is also helpful to them. Okay, thank you for watching. So thank you very much.